Number 2 went well. The only main thing I want to say about it is people did more than they had to for this question. I had a lot of people write the equation of the tangent line, and so you did more than the question was asking. I didn't take off for that, but on the AP exam they might, because it's a following directions issue. All it says is find the slope of the tangent line, and that just means the derivative. So this is the function. And it says we want the derivative at x equals -2. So we are going to find the derivative, and then we're going to plug in -2. I'm sorry, let me darken that up because I realize that's really washed out there. All right, so all we need to do is find the slope of the tangent line. So that's just the derivative at that point. So I'm going to rewrite this equation as x to the -2. We have division, that's going to be a negative exponent. And then for the power rule, we're going to bring the -2 down, and it's going to drop to a -3. So just remember, when it's negative, it becomes more negative because you're subtracting 1. And so to fix that negative exponent, it would go back down to the denominator. So this is your derivative. And we're going to plug in -2 for x. So that would be -2 over -2 cubed. So that would be -2 over -8, and the negatives are going to cancel, and it will reduce to 1/4. And like I said, a lot of people got that, but then they went on and did more, which I didn't take off for unless there was a mistake with it. But just be careful. You don't want to do more than what the question's asking for, because that means you didn't follow the directions of the question. It means you didn't understand what the question was asking. So don't do more than you have to. All right, so for number 3, this is the function, and we want the derivative at 0. So we're going to find the derivative, and then we're going to plug in 0. So derivative of just x would be 1 minus exponential is itself, so I'm basically just copying that down. And then there's a chain rule there. You have to chain on the derivative of 4x, which is 4. And then we're going to plug in 0. So this would be 1 minus e to the 0 is 1, and then times 4. So we have 1 minus 4, which would be -3. I had a lot of people get the derivative correct, and then when they came down to the next line, they just didn't bring the 1 with them, and that's a copy error when that happens, which is a real bummer. So just be careful, is all I'm saying there. All right, the next one I'm going to do is number 9. Now this one did ask for the equation, so we're going to do the whole equation for this one. So that's the function. Our point is 3 pi over 2, 0. We just need the slope. So slope comes from the derivative. So I'm going to find this derivative, and then I'm going to plug in 3 pi over 2. So this is going to be a product rule. And so it is the first function times derivative of the second, which would be negative sign, plus the second function times derivative of the first, and derivative of x would just be 1. And so we're going to plug 3 pi over 2 in for x. So this first part would just be 3 pi over 2. And then we have to do sine of 3 pi over 2. So off to the side here, let me draw 3 pi over 2 on the unit circle. It would be down here. And so that's the point 0, -1. Sine is the y value, so that would be -1. And then we're going to make that negative. So -1 would just be 1. Plus cosine of 3 pi over 2. Cosine is the x value, so that would just be 0. So this entire second part just goes away because that's going to be nothing. And so our slope is just 3 pi over 2. And so this is the point, this is the slope, and I'm going to put it together into the equation. So y minus 0 equals 3 pi over 2, x minus 3 pi over 2. And then the last one I had on my list to go over, and then I'll open it up to you guys, whatever you would like to see, was 16c. So we are asked to find the derivative of f of g of x. at x equals 1. So this is the chain rule. So you're going to have to write out the chain rule, and then we're going to evaluate it at 1. So it will be derivative of the outside, so f prime, leave the inside alone, and then we're going to chain on the derivative of the inside. And we're going to need the chart for this, so we're going to kind of pull this off to the side here. We're going to start with this. So we're going to do g of 1, and whatever we get, we're going to do f prime of that. So we're going to start here, g of 1. So here is the chart. So g of 1 is 4, so we know that part's 4, and then we want to do f prime of 4. So I know that this part's 4, and then I want to do f prime of that. So f prime of 4 is -7. So this first part's -7, and then times g prime of 1. Again, 1 is the value that we're plugging in. So g prime of 1. And so g prime of 1 is 9. And you can just stop there and leave it. That would be -63, but if you were having an off day and you accidentally wrote -62, then it would be wrong. So you're better off just keeping it like that. And I saw a few things in the chat. I'm sorry, I was just finishing that question. Let me go through and read. And you guys can all type in whatever else you want me to go over. Those are the ones I wanted to make sure I did, but I'll now open it up to you guys, whatever you would like me to go over. Someone asked if there's an SOL before the AP exam. There's not for this class. There's just the AP exam. Okay, and I'm sorry, now a bunch of people are typing things. Let me look back. All right, the first one I'm seeing is number 8. So let's go to number 8. All right, so for number 8, this is the function. And it says x has to be positive, so x is bigger than 0. It says we want the inverse derivative at 0. So we're going to make a chart for f and f prime, and then a chart for the inverse and the inverse derivative. And so whatever lands here is our answer to the whole thing. And it said we want that derivative at 0. So 0 is the x that we want to plug in for the inverse. And that means that that's going to be the output of the other function. Because again, if they're inverses, your input and output are going to get reversed. So we're going to set this function equal to 0 and solve it. And that will give us this x that's going to go here. So we'll add over the 32 and divide by 2 and square root. And typically you put plus and minus, but the problem said we want x to be positive, so just the positive 4. And so if this point is 4, 0, this one's going to be 0, 4. And now we need f prime. So I'm going to do the derivative of this function, which would be 4x. And the x value that we're plugging into that is 4. So if I plug in 4 there, 4 times 4 would be 16. And then to get the inverse derivative, you're going to do the reciprocal. So 1/16 was your final answer for that one. All right, and then number 15. All right, so you are correct. There are 3 links in this chain rule. The most outside is the 5th power, and then inside of that is cotangent, and then inside of that is 2x. So we're going to do the 5th power first. We'll bring the 5 down. It's going to drop to a 4. And then we're going to chain on the derivative of cotangent. Derivative of cotangent is negative cosecant squared. And then lastly, we're going to chain on the derivative of 2x, which is 2. So those were the 3 links in the chain. And you want to just leave it like that. You know, don't try to simplify that down, because if you make a mistake, then it's going to be wrong. All right, and then 14. So this one is going to be a quotient rule. And so it will be the denominator, so 4x minus 7, times derivative of the numerator. So derivative of ln is rational, so 1 over x, minus the numerator times derivative of the denominator, which is just going to be 4. And then it is all over the denominator squared. So I did it simpler than you did. I don't have your test in front of me. I don't know what you did. It would just be 3 links in the chain. So, and that's what the 3 points were for. So 1 point for each link in the chain. Anything else that you guys want me to go over from the test? All right, number 7. All right, it says find the instantaneous rate of change, and so that means derivative of this function at pi over 4. So we are going to find the derivative, and then we're going to plug in pi over 4. So this is a chain rule. ln is the outside function, cosine is the inside function. So derivative of ln is rational. That'll be 1 over whatever's inside. And then we're going to chain on the derivative of cosine, which is negative sine. And you can rewrite that in the numerator, so it's all together. And then I had some people even go a step further and reduce this to negative tangent. Sine over cosine is tangent. So that was awesome. I liked seeing that. But leaving it like this is okay too. So I'm going to just go ahead and stop there. And then we're going to plug in pi over 4. So on our unit circle, for pi over 4, both sides are square root of 2 over 2. Sine is the y value, cosine is the x value. So what you end up with is negative square root of 2 over 2 over square root of 2 over 2. But anything over itself is 1. So these are all just going to cancel. And you still just have that negative sign in there, so negative 1.